Hello and welcome to the Introduction to Digital Image Processing using Matlab. In the series of tutorials, we will discuss the use of Matlab for image processing specifically. Now, just to get started, this is how the Matlab looks like. You can change the layout. So this is the default layout. We can have the only command line. We can have history and command window. So you can change the appearance. We will generally go out for the default appearance. Now Matlab, you just have this cursor here. You can type in whatever commands you want. So suppose I can do mathematical calculations, and there's always a variable called answer which is assigned to the calculations that we have last performed. So 6 plus 7, 8 minus 4. We can do various options, mathematical operations. So this is almost like a calculator here. We can also say format long, and then if I do the same calculation, you can see that the long format of the answer is got. Then we can do this an inbuilt command to find out the square root. So this is how it looks like. Again, the format is long here. The sign values pi by 6. So these are all inbuilt values. We have log. You can see that when I do a log, I just forgot the brackets here. So log of 10. So you can see that this is what we get. So this is basically log to the base 2 that we have. I can say log to the base 10, and I get the answer 1. So I can change the bases over here. I can assign the bases and do the operations on whatever operand put inside the brackets. Then I can define variables. I can say maybe A is 3.45, B is 7.8, and tan B. So this is the tangent that we get. We say A into tan B. This is what we get. Then I have an inbuilt command called who. This will tell me what variables I used till now in my workspace. So we have A and B variables defined. I can say I can get the details by using who s. So you can see A, B, their sizes, and as well as an answer which is telling me the last result of my calculation done is displayed here. So the size, the byte size, the class, everything is defined using whos. The Matlab is so powerful because it is able to manipulate matrices very well. So we can just maybe define a matrix here. I'll just space it out 2, 3, 2. So this is one row of 4 columns. The second row would be any values I can put in, not necessarily 1 digit, 2 digit, they can be anything. I can have negative values also. So you can see I have defined a 3 row by 4 column matrix, and I can also get the values of this matrix if I want, suppose the second row and 4th column. So this should return second row and 4th column. So 4 should be returned, which we get here. Similarly, I can do other options. You can maybe check with 1 comma anything which is not here. So you can see that the index exceeds the matrix dimensions because we had a 3 cross 4 matrix here. Now we have also the order defined. So the order of this matrix is defined like this. This is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. What do I mean by this? So if I say suppose 12, I should be getting 6. Why? Because this is how the index is defined. This is the first, this is second, third, fourth, fifth, sixth, and moving on like this, we get this as the 12th element. We can check with second element. So it should be 3. Yes, it is. So this is second, first, second, third, fourth, fifth, and so on. So this is the direct index of the matrix. Rather than giving a row of comma column, we have just given an index to it. Now then we can also have, we can take the elements out. So suppose I want 6, 10, 1. So you can see the 6th element, the 10th element, and the first element are output as the answer here. Now I can also use a colon operator. So I suppose I say 2, 16 or whatever, 19. So what does it mean? I start from 2 and I end till 19 here, and I have my step size is 3. So the first element is 2, then plus 3 is 5, plus 3 is 8, plus 3 11, plus 3 14, and then 17. Plus 3, if I do it, it exceeds this value, so that is why it is still 17. So this is basically used at various places in loops and everything. So I just use this colon operator. I can also extract. So suppose I say second row and first column to the third column. So second row, and I said first to third, to 3 6 12. That I should get that. So 3 6 12 is here. I can also index it on the rows. So I say 2 to 3, and maybe I just take out the first row, first column, sorry. So second, third elements, 3 minus 3. So we get it like this. I can get all the elements. I can just say 3 and give a colon, so it means all the elements are included. So in the entire third row is displayed here. So I can do various other operations. I can define another matrix B, and maybe I'll define it like this was of size 3 cross 4. So I'll define another 4 cross 3. So this is my 4 cross 3. If I want to do A into B, I get the values. So the normal matrix multiplication is performed and the answer is stored in the variable ANS, which is the short form for answer. Similarly, I can do other operations, like I can just say 2 into A minus 3 into B. So the dimensions do not agree. We know that the minus operation can be performed only when the number of rows and columns are the same. So obviously that is why this is not working, because we had taken the matrix as 4 cross 3. So apart from this, I have a dot operator. So if I want to do operations just on the element, then I can say A dot to the power 2. Yes. So we can see here that, just to recapitulate, what was A? This was my A. What am I doing? I'm squaring all the elements. So I'm just saying the dot operator means that operate on each and every index individually. Each and every element, each and every element is operated on individually. So I'm squaring all the elements here. As you can see, this is the answer that I get. Similarly, I can just say maybe 1 dot A. So I'm getting the inverse of each and every number of A. We can say inverse A. Okay, so this was obviously it has to adhere to the matrix rules. So maybe I'll make another matrix of 3 cross 3. So this is my matrix 3 cross 3, and I say inverse X and I'm able to get the inverse, the value, through just using this inbuilt command. I can perform the transpose by using the dash command, and you can see that this is coming here, so 1 4 2 here, and the transpose of this matrix is here. Similarly, I have another function, flip ud, which is flip up down. So if I say flip ud up down x, so what is it doing? The lower elements are swapping, and it's an inverse basically. So it's a mirror image across the horizontal axis. So 1 2 3 come here, so it's an up down flip. I can also perform a flip left right. So I'll again do this, and it's across the y axis. I'm getting this. So these elements have been flipped, and the center one remains the same. Similarly, I can just say rotate 90, rotate 90, and I give x. So you can see all the elements are rotated by a 90 degrees. So it's just a rotation like this, 1 2 3 here, and this gets rotated. So each and every element is just getting rotated. Then there's another command called reshape. Reshape produces a matrix with elements taken column by column from the given element. So suppose I have this x over here, or I'll just recheck what my a was, okay, and I say reshape. So right now I have 3 rows and 4 columns. So I want to reshape this. I have how many elements? I have 12 elements. So I want 2 rows and I would have 6 columns, because the number of elements cannot change. So that is why the number of elements should remain the same. So 6 into 2 is 12, 4 into 3 is 12. So that is why this should work. And what's happening? The reshape is done. So first these 2 elements are taken, 1 and 3, then minus 3 and 2, 6 and 7, 3 and 2, 12, minus 7 and 2, and 4 and 6. So that's how a reshape is performed. I can do more reshapes, like I can say A, again it should adhere to the 4 comma 3, so I can say 4 rows and 3 columns. So you can see this one element is added here, then these 2 elements shift here, and this is what my result is. So this is how we can use the reshape command. Then we have something called a zeros command. This is an easy method to generate matrices with all 0 elements. So if I just give one number, a 4 cross 4 matrix is generated with all zeros. If I give 2 dimensions, so I say 4 comma 5, 4 rows and 5 columns, 0 matrix is generated. It can be a multi-dimensional matrix, so I can just say 2 comma 3 comma 4, 2 elements all assigned in the 3 dimension. So then we have something called a plot. I can just say plot, and I can say maybe x comma, I say tan x. So this is how my plot will look like. The values of x across here and tan x on this axis. Whenever I want a new figure to be displayed, I can just say the command figure, and you can see a new blank figure is generated. Otherwise what will happen is that the last previous figure will be written on, and that will be lost. So I just use the figure command. So this brings us to the end of this first introduction to Matlab. Now in the next one we will look at the commands more specific to the image processing toolbox. Thank you.